My name is William Dixon, and my project is on improving the effectiveness of carbon sequestration on farms. Carbon sequestration is when carbon is taken from the air and by natural processes is absorbed into the ground by plants and other fauna. The research direction that I went through was that I will be studying different farms and the different sequestration methods those farms have and comparing the effectiveness, the difficulty of implementation, and the cost of upkeep of all those methods, and comparing them to determine which one is best suited, which method is best suited for which situation. Like if you got a small farm, you got a big farm. If you don't got a lot of time, you got a family farm. That's what I'm going to be looking at. So I gathered data from two different farms, and on each farm I gathered control samples and non-control samples, the method samples. Now, I would find the average grams of organic carbon through methods like loss of ignition and acid digestion in the base sample, and then I'd find it in the method sample. And then by dividing the method sample by the base sample, this allowed me to get the sequestration change percentage, which is how much more effective the soil becomes at absorbing CO2 and keeping CO2, like how much more CO2 there generally is per gram of soil. This graph shows why the sequestration improvement percentage is a better metric than just a flat number. Because as you can see on the blue graph and the red graph, it's the same improvement in base number and base grams of TOC improvement from control, but clearly it's improving the blue one's effectiveness by 2 times, while only about 1.25 times for the red one. So by doing the sequestration percentage, as you can see by this third graph, it actually allows you to get a better metric for how much more effective each method makes the soil at sequestering. Now, from the results of my testing, as you can see, the graph clearly shows that no-till is both less invasive as a method and also sequesters more carbon and just improves the sequestration percentage. But the only downside is no-till methods generally use more non-renewable resources like fertilizer. You have to keep buying. Let's say, for example, you're running a small farm and you don't have the manpower to work a big hoe or tractor or whatever, then no-till is going to be your way to go, because that is easier and also less invasive, while also delivering more carbon to your crops, making your soil healthier. So generally speaking, no-till is more viable in more situations, but it does have some drawbacks, but my research concludes that overall, no-till comes out on top.